Today we are going to be talking about the least common multiple, and I know that there are several different ways that you can find the least common multiple. You've done them in different classes, but we learned how to do our GCF using prime factorization, and I told you that when we did that, the whole reasoning is that we could do both GCF and now we can do our least common multiple using that. So you don't have to do two separate methods to do two separate things. You can do one method and you can find both of them at the same time. So what's kind of funny is that the greatest common factor, that one was, when we looked at the prime factorization, the one that least often appeared. What did they share? This time, when we're looking for a multiple, the word right in there, M means most. This time we're looking for the most times it appears. So that's going to be the only difference of what we are going to be doing. So at example number 1 right here, we're going to do the prime factorization of 9 and 12. So 9, if we divide by 3, we get to 3, and we're done. So we have 3 times 3 as our prime factorization. For 12, I'm going to start with 2. We go to 6, divide by 2 again, we go to 3, divide by 3, and we are done. So we have 2 times 2 times 3. All right, now, let me just copy that. Ooh, come back. I'm going to pull that work down here. And that's all that we need for the LCM as well. So I'm going to show you the difference. And now what you are going to do for GCF is what they share. So the only thing that I see that they share is 1, 3. One set of 3. So that's all that we are going to write down for the GCF. And notice that that is smaller than 9 or smaller. Now the LCM should be 12 or bigger because it's the biggest number. So this time is the most times it appears. So now if I look in here, I'm going to start with the lowest and move to 2. I see it appear twice in this text. I'm going to circle it. I see it 3 appear once, but in this guy he appears twice. So I'm also going to highlight him. And then I'm going to write down all of those numbers. So I have 2 times 2 times 3 times 3. Which gets to 4 times 9. So these two together, and then we get to 36. So that is the biggest number or higher. So kind of neat how we can do both versions right there. Okay, LCM of 10, 12, and 140. So for 10, we start dividing by 2, we get to 5. And divide by 3, divide by 5, and we are done. So it's just 10 times 5. 12, we start with 2, and we get to 6. We can divide by 2 again, we get to 3. And divide by 3, and we are done. So 2 times 2 times 3. So for 140, I can move to this way. For 140, we're going to start with 2, we get down to 70. And divide by 2, we get down to 35. Can't divide by 2, can't divide by 3, so let's go to 5. Get down to 7, can't divide by 5 again, so we go to 7. And that means that we are done. So looking here, I have 2 times 2 times 5 times 7. Go backwards. All right, now what are we going to do? We're going to look at the most times it appears. So let's go ahead and take a look at how many times the 2 appears. He appears twice, or once in the first guy. So he appears twice in the second guy, as well as the third guy. So I'm only going to highlight one of them. I see a 3 appear. I'm going to highlight him. And I see a 5 in the first guy, and I see 1 5 in the bottom guy, so I'm going to highlight him. and I also see a 7. So that is everything that I'm going to write down. So I have 2 2s, I have 1 3, I have 1 5, and I have 1 7. What's nice about that is that we don't have to sit there and do all of those multiplications. And so I'm going to go ahead and start with 4 times 15 times 7. We know 4 times 15 is 60 times 7, and we get to 420. So do whatever is easiest for you. Okay, LCM of 25a and 40a squared. More of the stripes in there. So we have 25a, and we have 40a squared. Remember when we do the time factorization, we just write down how many times the variable appears. So 25, we'll start with that. We can divide by 5, and we get to 5. We divide by 5 again, and we're done. And we also have 1a in there. 40. We can divide by 2, and we get to 20. We'll divide by 2 again, we get to 10. Divide by 2 again, we get to 5. Not divide by 2, not divide by 3. Start dividing by 5, and we get to 1. How many a's are we going to write down? 2 of them. So again, we're going to look for how many times it most appears. So the lowest number I see is 2, and I see it appears 3 times, so I highlight it here. Next, I'm looking for 5 is the next lowest number, so I see it appear twice in this guy. And how many the most times the A appears is twice in this one. So I'm going to highlight him, and we get all of those numbers together. 2 times 2 times 2 times 5 times 5 times A times A. So I have 8 times 25, and I have A squared. And 8 times 25, I want you to think about that you have 8 quarters. How much money do you have? $2, that's right, and we're going to make that 200 cents right there. And that is our LCM. Okay, 10-second head start on the LCM of 14x to the 4th and 21x squared. All right, your head start is over. Let's take a look at the 14x to the 4th. So we have 2 times 7. Can't divide by 2, can't divide by 3, can't divide by 5, goes straight to 7. We're down to 1, so 2 times 7, and you list the x 4 times. For the 21x squared, we can't divide by 2, so we start with 3. And we get down to 7, can't divide by 3, can't divide by 7, can't divide by 7, and we get down to 1. And we lift up the x twice. So going back into how many times they repeat, I see a 2 comes up once, a 3 comes up once, and the 7s also appear once in each, so I'm only going to circle one of them. And then the most x's I see appear are these 4. So write it all down, 2 times 3 times 7 times x times x times x times x. We have 6 times 7, this is the 42x to the 4th. And now for a little bit of fun. We're looking at a pattern. I'll give you 7 seconds to copy that pattern down. So what I'm noticing about the pattern is that I went star, circle, square. Star, circle, square. So that's the pattern in the first guy. And the next thing will be the star, circle, square. And the second guy, the star, triangle, circle, square. Star, triangle. single circle square. So if you notice in the first one, I am repeating every 3. In the second one, I am repeating every 4. Okay, so what's my question, right? Here's my question. When will the stars exactly line up over each other again? Here's what you know right there. By everything that we've been doing. That's our LCM. That's the least common multiple when it appears. Okay, well, 3 and 4, those are pretty small numbers. We know the least common multiple between 3 and 4 is that's right. So it'll appear on the 12. Now, if we didn't know that, I would again go through. Maybe then there's 2, we're going to see it every time. So if we didn't know that again, we would highlight 3 and we would highlight 2 2s, and that does get us to 12. On a 12 picture of each of those patterns, that's when they will align. We don't believe certain patterns. A lot of fun, 24 little pictures. Okay, last but not least, when we did our GCF, we looked at how to determine which one was greater by reducing it to make sure that it was greater as to compare them, which is great, except that sometimes you can still look at them and you're not quite sure. So this time we're going to use the least common multiple between the 3 and the 8, so I'm just going to multiply this together, which is 24. That's what I want to do to compare both of those. I'm going to multiply the 8 to the 2, just getting common right here, so we get 16, and 3 to the 5, and we get 15. So this one is bigger. And that will finish the off. Alright, so going back up to the top, where I conclude right here. So again, we're talking about the least common multiple. I know that there are other methods out there to do the least common multiple, and you are going to get some bigger numbers, much like number 2 in our example. So again, I really want you to try to get used to this methodology so that when I ask on your test for GCF and LCM of the same numbers, you don't have to do 2 separate methods. You can do one method